So the topic is data denormalization. Yeah. So the idea is we intentionally add data redundancy. Yeah. In our original data, so here, another part. Yeah. So when we look at the data normalization topic, so last time we spent a lot of time discuss this topic. Usually, so based on general understanding, people like to reduce the data redundancy as much as they can. Yeah, so that's the general idea. Yeah. Yeah. But in the real world situation, so there are some cases either you cannot do it or you don't want to do it. Yeah. So one question.
Yeah. So with stuff like for the process, you have things like what search engine optimization is for, I guess, like not directly, of course, but like when it's indexing the web page,
good,
compile all those,
right,
and then know ahead of time. Oh, this web page has this.
Good,
okay,
right. That's the key idea. Yes. I just use our So he talk about the Google search engine main idea. So I want to use that story, put it in our database context.
Okay.
Yeah. So in our situation, so use that as example to explain our data denormalization concept, importance. Yes. Yeah. So I will get there. All right. Oh, Nishant join us. Two students join us. All right. So here, all right. So two cases we need to, realize the data denormalization. One is it's hard to avoid. Yeah. So when we design a database, in order to, run the basic queries smoothly and efficiently, we have to use controlled redundancy. So that's one. But another is different. So another redundancy is the one I want to talk about here. So we intentionally derive the data in order to support fast performance of some special type of data search. Here, this Google search engine is an excellent example. So in this topic, so let me, in the next slide, I want to describe that story and try to fit in our data denormalization, this framework. Yeah. All right. So, but there is another interesting application. Also, we use the similar idea. Another interesting, today I do not have time to talk about that. So if later at some time, if I have chance, I may talk about another story. So that's the Google Map application. That's also related to this topic. So the Google Map, I think you use that application a lot. Yeah. So when you type a address, so you get a bring up a window, you can see the region, the map of the region, with your address in the center, at the center of that region. Okay. Yeah. But you need to load the map data, right? You need to load the map data. Yeah. So when you type address, so you provide, so your address has a longitude, latitude. Okay. So you some kind of coordinates, coordinate. So you send that coordinate to the Google server, Google Map server. Okay, so longitude, latitude to the Google Map server. Then the Google will send you map data, but the map data covering the whole Earth, that's very big. So the Google does not need to send you all the data, huge amount of data. Only need to send the data covering your region. The region contains your address. So how to get that request search very fast? That's another interesting story. But today we only talk about Google search engine. Okay, so this one, if later sometime, so I have chance, or I use the supplementary video talk about the story. All right. So now, so let's look at this Google search engine. The search engine, the idea why it can do so fast, pre-processing approach. Pre-processing. We want to do pre-processing. We do computation before the user submit the requests. Pre-processing. That's all right. So let me describe this idea here. Okay. The Google search engine. Application. So our view of angle, we want to look at from the data denormalization point of view, on the story. All right. So the goal. First, let's understand the data we need to process. The data here. The web pages in the whole world, right? So that's the data the Google, they need to process. They need to process it. Or more specifically, the URLs, each web page has a specific URL. Okay, So the original data, the URLs of all the web pages. In the world. That's the data, original data. Okay, to be processed. Then the search operation here. Input keywords. So keywords based search. Here we do keywords based search. Okay, keywords. Input. So this is the input. Okay. All right. So then we send a request. Okay. Hit enter. The users send the request, send the keywords as the input data to the Google server, search engine, the server. Okay. So the output URLs containing the keywords. The keywords. In pages. Okay. So here the pagination is important because it's very common. The URLs containing URLs of those web pages. Now here, when we say URLs, we refer to their corresponding web pages. So in general, you may have millions of pages containing the keywords. It's impossible to send, millions of URLs to you, not necessary. So in pages, so here using the pagination, every time you only see one of the pages, one of the million pages. So that's relatively small amount of data, one page of data, small amount of data. And we know the response time is very fast. In general, the response time is very fast. Right? So you get the response immediately. Okay? So usually less than 1 second, fraction of second. So 0 point certain number second. Okay? Yeah. So the typical response time. Yeah. So think about how to get the search result. Millions of pages, that search result. Yeah. URLs, what do you see? The first page URL, right? Yeah. First page URL. Yeah. Then you can navigate to other pages if you like. Yeah. All right. So why this application can do the keywords-based search so fast? So we want to, look at this question. Why it is so fast? Okay? Because, to process keywords-based search on a large number of web pages, that's very time consuming. Very time consuming. So here there is a basic fact. I want to point it out. Basic fact. To do keyword based search in large number of pages is very time consuming. Consuming. Okay? Yeah? All right. But you cannot let your users, your customers, wait there for a long time. No, you cannot. So you have to give your customers immediate response. So then you should develop some very smart algorithm, very fast, smart algorithm, indexing. Okay? Yeah. So that's the mention at the beginning, the indexing technique. You need to do pre-processing. Here, we do pre-processing. So what kind of pre-processing? Indexing pre-processing. Okay? So indexing idea. The main idea is this indexing. So what's that? So you do pre-processing here. Now, so before the users submit their requests, you do the most of the computation. So that pre-processing. Yeah, even before the users submit their requests, you do the computation ahead of time. So that's the main idea. So this idea is very important. Yeah. Pre-processing idea. So what do you do? The pre-processing. All right. Do the mapping. So the indexing means do the mapping. So mapping what? Yeah. All right. So first, you need to, because you need to visit all the web pages in the world, right? Visit all the web pages in the world. Or let's say process all the web pages in the world. Yeah. So one step. So process. Data processing. Process. Okay. Process all the web pages. Okay. Yeah. When you do process all the web pages, what do you do? Okay. Keywords URL mapping. Okay. So the mapping, keywords, URL mapping. Okay. The keywords are extracted from web pages. So you need to do keywords extraction from the web pages. So take some time, okay? Yeah. Take some time. Yeah. But so usually this kind of work, Google, they use a special type of small programs. So they call it spiders. Yeah. Spiders, some automatic programs. Yeah. So they send spiders. So the programs visit all the web pages in the world automatically. Okay. So, okay. So that's little programs called spiders. Spiders crawling on the web. Yeah, because people call it the web, right? So, you know, World Wide Web. Yeah, so spiders, you know, crawling on the World Wide Web. Okay, so visit all the URLs in the world, large number. So they use a lot of computation resource. So they have a huge number of servers. Okay, the spiders sending out, you know, huge number of spiders sending out, you know, at the night. So all the time. So visit all the web pages in the world, then process the text. So for each web page, process the text, extract the keywords, then do the mapping. So create a table. So each keyword, there is a URL. So create a mapping table between keywords and the URLs. That kind of work. Yeah. One thing, yeah, because this method, there is an important property for this method. Yeah. Because when a new web page is created, it is not necessary after a new web page is created, the search engine can cover that page and make the keyword URL mapping immediately. So usually it's not necessary. Yeah. It may take a few days. Even it takes a few days. Those people who create web pages, they feel fine, right? Because at the beginning, yeah, so they are patient. So they are patient. For the search engine to cover your particular web page, it may take a few days. Yeah. Because there are too many web pages in the world to be processed, right? Yeah. So in order to let the search engine cover your particular web page, it may take some time. Yeah. So for this application, it's not that important. So people have the patience, you know, waiting for a few days to, you know, to get a search engine cover new web pages. Okay, yeah, all right. So then, so here the pre-processing does a large amount of mapping work. Yeah. huge amount of mapping work behind the scene. Yeah. Yeah. But, so that waiting time behind the scene, you know, so the delay, so the page to be covered, that delay time before the page is available in the search engine. Yeah. So that's the initial delay, right? Initial. As soon as the search engine covers your page, then it's visible all the time, right? It's visible all the time. Yeah. Okay. Yeah. All right. So this kind of background processing work, data pre-processing, okay? Yeah. And this keywords, URL mapping, derived data, right? Yeah, so they're derived data. They are not original data. Derived data. They are not original data, right? Yeah, because if the data is removed for some reason, get lost, lost the data, yeah, due to some reason, the data is lost. For some reason, it can be recovered, right? So you run the same pre-processing process, you can recover that data, okay? So it's not original data, so it's derived data. But this derived data, when the users submit requests, type the keywords, then the Google search engine, it does not need to do the real-time keywords-based search because it's impossible. It's too time-consuming. It's impossible. So actually, what the search engine does, just visit the mapping table, okay? The keywords URL mapping table. Then retrieve the results, do a query, okay? Do a SQL query from the mapping table. Then first it returns aggregate information, aggregate. Yeah, how many pages contains this keyword? That's the aggregate information, okay? So it sends it back aggregate information, yeah, fraction, millions of pages, that number, okay? Yeah. Other than that, send back one page of the URL. So that's a relatively small amount of data. That's also fast, okay? Remember, in one of our previous lectures, I talk about one keyword in MySQL, yeah? So remember, in MySQL, the select statement, yeah, MySQL, SQL, in that select statement, I talk about the limit keyword, right? We use this limit keyword, we can retrieve just the one page of the data. Yeah. We do not need to retrieve all pages, large amount of data, not necessary. So you only need to return the first page of the data upon the request, keyword requests. Yeah. That's pretty simple, that's pretty fast, right? Select some table and limit the first page of data. How fast it is, right? Yeah. Yeah. So that's the impact of this pre-processing idea. The improvement is huge. People get an immediate response. Yeah. So this story, so you can learn, because later sometime in your real world problem solving, yeah, so probably you need to develop some web applications in some situation. You may want to borrow this pre-processing idea, okay, to speed up your response time, the response time of your web application. Okay? Yeah. Yeah. So borrow this idea. Yeah. So later when I have a chance to talk about the Google Map, people use the same idea, pre-processing idea, for map. The map data, because the map data of the whole world also huge amount. How can you find, given a particular location, how can you find the appropriate region that contains the given location in a short period of time? Yeah. So you don't want to go through all of your map data, right? So if you want to go through all your map data, that is too slow. So you want to get to your particular region as fast as possible. Okay? So that step, although slightly that idea a little different from this idea, this indexing idea, but there is some similarity, but also some important difference. So later, when I have a chance, I want to talk about that idea also. So here, what do you learn from these two stories? Just how to use some smart way to do the pre-processing that generates derived data to help speed up, to help your application speed up upon the user's requests. All right? Yeah. Okay, so we finished this topic. Yeah. Next, the last slide of this part, responsibility for controlled redundancy. Yeah. Who is responsible for controlled redundancy? Right? Yeah. So this, the final issue we want to discuss. Yeah. Someone is responsible for maintaining controlled redundancy. Yeah. In our textbook, there is this sentence. It says, DBMS should have the capabilities to control this redundancy in order to prohibit inconsistencies among the files. Should, okay? Yeah. But it's impossible. Yeah. Although people like to make the DBMS have this capabilities, but it's too hard. In the real world applications, it's too hard to make the DBMS do that because it's not smart enough, right? Because the controller dependency could be very complicated. Yeah. So it's very hard. Yeah. In future, if AI is used, it could happen. Okay? Yeah. So in future, it could happen. It could happen, yeah. Right now it's impossible, okay? It could happen with AI, okay? Yeah. Yeah. But not easy, not easy. Yeah. So then, if the DBMS cannot do it, then another group of people are responsible for enforce this kind of control redundancy. All right. So what DBMS can do, enforce certain constraints, certain relatively simple constraints, not complicated constraints. So we know control the redundancy we can understand as special type of constraints. Okay? So usually complex constraints, not simple constraints. Cannot enforce business rules directly. We know for the relatively hard business rules, it is too complicated for the DBMS to to enforce automatically. So what I mean automatically, okay? Automatically, so that means with easy setup, the DBMS can do the enforcement, okay? With easy setup, the DBMS can do the control the dependency, redundancy, control the redundancy, yeah. So that means if DBMS has that capability, then we say it can do it. Okay? If with very complicated programming work, then we shift the responsibility to programmers, right? Not DBMS, because programmers, they need to write, a lot of code to enforce the controlled redundancy. Yeah. So the responsibility, so that in that situation, that's it. So it's the responsibility of application programmers. So, yeah. All right. Yeah. So then people need to write programs. Could be a lot of programs. And it could be stored procedures. People could write stored procedures to enforce the complicated business rules. Here specifically about controlled redundancy. Okay. All right, so I finished part B. Then let me move to part C, new topic. All right, so here, so at the beginning of the, all right, so let's learn some also basic concepts, but this time we move level a little higher to understand the background knowledge of databases. All right, yeah, so here the title, part C, object-oriented databases, a special type of databases. Here, but at the beginning, I want to point it out. This type of databases are not very useful in the real-world applications. Not very useful, okay? It's not, okay? But why I still talk about that? Because this concept, so people, the researchers, they did a lot of research in this topic, this type of databases, but the real-world implementation is not very successful. So not many people adopt this special type of databases. But then there is an idea modified. There is a slightly different idea. That idea is very, very popular in the real-world applications. So that's the reason I want to discuss this topic as important background knowledge for database programmers. Yeah. All right, so let's look at the concepts of database catalog. So last time I used a diagram to describe the catalog concept. So here, so let's review a little bit. Yeah. So very basic concept, the catalog. Yeah. All right. So the catalog in a database. Yeah. So let me recall a little bit. Yeah. So here, let me draw a simple diagram. In a computer, or this computer we refer to database server, a database server, okay? Yeah. DB server. And for the data storage, yeah, so we only look at the hard drive because we store our data on hard drive. Okay. Then, when we store our business data in a DBMS, so the structure to organize the data, there are two parts. Yeah. So remember, in the diagram, we draw two cylinders, okay? Two cylinders. Okay, all right. One block, one cylinder block, we store the business data, okay? The business data. Yeah. So this data, business data, we call the primary data. Another block, supporting data, okay? So not the original business data. So supporting, in order to make the business data easy to use in the DBMS, we need another set of auxiliary, okay, supporting data. So this data, so we call the secondary data, okay? Secondary data. Okay. So that's the metadata, okay? That's the metadata. Also, the database catalog refers to this cylinder, okay? Yeah. So this metadata, secondary data cylinder, okay? So that's what we learned before here. So I draw this diagram to refresh your memory a little bit. Yeah. So it contains useful information about the data in the database. Yeah. Supporting or descriptive, the meaning of meta, descriptive, right? The descriptive data for your primary data. That's the meaning of meta, okay? Yeah. What does this metadata contain? So typically containing structure, description of the structure of your business data. Constraints, yeah, certain constraints. Yeah. So you have to follow these rules, constraints. Okay. Type of storage format, the data type. So what type, what format do you use to store the data? So this kind of basic information. All right. Yeah. And this metadata is accessed by DBMS directly. Okay, DBMS directly. Yeah. For our users, so we do not access this data directly. We access indirectly. Indirectly through the interface for DBMS. We need to use some, user-friendly interface to access this data. Okay? Yeah. So in our exam, remember we use the PHP MyAdmin, that web application as the user's interface to access this part of the data, metadata, to control the real databases. So that's the logic, okay? So that's the, relationship among these types of data, different types of data. Okay. All right. Then sometimes people call DBMS catalog, sometimes people call database catalog. So the same thing. Yeah. Same thing. Yeah. Same concept. Yeah. All right. A database about the database objects. Yeah. So here. Yeah. So each database is treated as an object, a database object. Okay? So a database, then you need to maintain the object. Yeah. So there is one higher level database used to control all other databases. Yeah. So if you look at the MySQL DBMS, yeah, here we use the MySQL as the example, MySQL. MySQL has a top level database. Okay, so that database is built in. Yeah. So MySQL has a top level built in. database. So that top level built-in database contains the database objects for all the other user-created databases. So sometimes you can access this top-level database to get information about, other user-created databases. So there is one. So in MySQL you can see, some schema, info schema, some special name. Okay. But usually, for us, it's not important for us. Okay. So usually, we do not use that. Okay. But in some special situation, we may need to use that. Okay. The top level database in DBMS. Users are not allowed to modify the details in it directly. So, because you may messed up, right? So you should not, because the internal data is stored in a very special way. So it's not allowed for ordinary users, programmers, ordinary people to, directly act, if you try to modify, you may mess up. All right. Users can only view the tables in it through DBMS interface. Users, GUI, user-friendly interface. Only DBMS can access it. DBMS knows how to access it in the right way. All right. Then, here I want to mention compare our traditional DBMS with NoSQL system. The NoSQL system do not have the metadata. The reason is very simple. Because the NoSQL system, the data format for the NoSQL system, key value pairs. Okay. Key, search key, value, key value pairs. That's the only structure you use in NoSQL systems. Then, under that only structure of the data, so you don't need to describe the structure, right? Because that's the only one. Because we use metadata, we describe the structures used by databases. Here, no need to describe. So that's the only one used in the NoSQL system. Then, what's the benefit? So here you can see NoSQL is a extremely simple. It uses extremely simple structure of data, not like a relational database. When we use relational data, the structure of our business data could be very complicated, right? That's the relational database. But the benefit of the NoSQL system's simple structure, as soon as the data available in the database, then your application can, so under some simple setup, then the data can be searchable immediately. So this property we need to use in social network applications. When posts, tweets, the messages in social networks immediately become searchable. As soon as people enter the posts, tweets, then become searchable immediately. without complicated Google search engine type pre-processing. We know pre-processing extremely slow, complicated, time consuming. Okay, so here people don't want to make the social network respond to the new posts, new tweets visible to the web community in a very slow way. Yeah. All right. So for that reason, this new type of DBMS, non-traditional, new type of NoSQL systems are created, yeah, to provide that fast search. So you only need to enter hashtag, right? Yeah. After you know, in your posts, tweets, you only need to, you know, if you want to make the search tool can process your posts, tweets, you just put a few hashtags. Then immediately it becomes visible to the whole world, the web community, social network community. Yeah. So that's the, you know, the main reason. Yeah. So this new type of non-traditional DBMS becomes very important in the current business world. All right. C.2, integrity constraints in DBMS. The DBMS can do some relatively simple constraints, you know, automatically, but you need to set up. So we as database designers, so we need to, you know, define certain constraints using SQL statements to define constraints. Yeah. All right. So here, let's look at those simple constraints. Yeah. Data integrity issue. Yeah. So you need to make sure so your data, you do not violate, so you do not damage your data integrity. Okay? Certain conditions on data must be applied. Yeah. All right. Who will enforce them? Who will enforce them? So two parts. For the relatively simple constraints, we can set up in DBMS to make it DBMS enforce those constraints. But for the complex constraints, the DBMS cannot do it, so not that smart. Yeah. So we as programmers, we need to write, yeah, it could be complicated programs to enforce those constraints. Yeah. All right. So application programmers or DBMS, so two parts. Yeah. All right. Do as much as possible. Yeah. So DBMS actually can do the relatively simple part. Although you want to make it do more, but it has its limitation. Yeah. All right. So here, let's look at a few concrete constraints. The first one, specifying data type for each data item. That's a simple. Yeah. So integer data, string data, and all other data formats. Yeah. So they are constraints. Yeah. So we can, you know, use appropriate data formats to describe our data. So that's one simple type constraint. So DBMS can enforce that easily. Okay, all right. Yeah, another one called the referential integrity constraint. Yeah, a special type of constraint called referential integrity. So what's that? Yeah, related to foreign key. Yeah, foreign key. Later we will discuss this foreign key more. So here I only describe a little bit what's the foreign key. Yeah, yeah. This constraint we can make DBMS to enforce this integrity. Yeah. The foreign key is a record in one file, a record, one row of data, a record in one file must be related to records in other files. So in other files, we may want to refer that particular record, okay? That particular record. Yeah. So that kind of referential integrity. Yeah. So you need to make sure the data, with that kind of referential relationship, you maintain the data integrity. If you change one piece of data somewhere, then you need to make sure in other places, data sometimes should be changed accordingly, right? Otherwise, you break the data integrity, okay? Yeah. But this kind of integrity can be enforced by DBMS. So we do not need human programmers to do the enforcement like this, because very simple. Yeah. Another one is the uniqueness constraint. So what's that constraint? Yeah. Sometimes we want the values of a particular field. Yeah. So in each table there are many fields, right? The columns. Yeah. Columns. Yeah. Sometimes we want to make certain columns, the values of certain column uniqueness. Yeah. So we call those fields key. So what's the key? So here, the concept. Later we will discuss more about the key. What's the key? Key concept in our database context. Key context is a field. So here, first we refer to a field in a table, okay? A field with unique values. If a field has this property, we call it a key field. Yeah. Otherwise, if a field does not have this property, yeah, some values can be duplicated. Yeah. Some values can be duplicated. If a field allows duplicates for certain values, then we cannot call it's a key field. It's not a key field. Yeah. So the uniqueness constraint. So here we need to tell DBMS, enforce uniqueness constraint if we want to make one particular field a key, right? So, yeah. So here, why we want to make a particular field key later, yeah, we will know the key concept is important if we want to make our search very fast. Yeah, so we need this concept, the key field. Use key field to support fast search. That's important. Okay? Yeah. So this concept. In module 5, when we talk about fast search algorithms, we need to use this key field, this concept. All right. So this constraint. So we make a DBMS. Yeah. So definitely, so DBMS can do it easily. Very easy. Yeah. But the last type, business rules, yeah, it could be very complicated. Although some relatively simple business rules, we can use SQL to describe the constraints and enter as the metadata for our databases, metadata. In our metadata, we can use the SQL statements to describe relatively simple business rules. That's possible. Yeah. But here, we want to look at the complex part. For complex business rules, we may need to write programs. We may need to write, could be very complicated programs. Yeah. You can use your application programs or use SQL to write stored procedures. Stored procedure, you can enforce the business rules. Yeah. And usually, using stored procedures better than other high-level programming languages. Yeah. The reason is simple, because you only need to write it once, right? Write it once, then all other modules can call these stored procedures to enforce business rules. Okay. Yeah. So better than you use high-level application programs to enforce these business rules. Yeah. All right, so that's this problem. Yeah. All right. Next topic, C.3. This time we need to look at this object-oriented databases. Yeah. So we want to see how to store objects in big database. So this idea. Yeah. But this idea is it's a research project. Okay. This idea cannot be commercialized. It's, after the research project, in the experiments, in the real world, not very successful. Most people don't like to use it. Too complicated. Okay? The benefit is very little. So people drop it. But here, we learn this topic as the background knowledge, because with this background knowledge, you can understand other concepts, other related concepts. All right. It's a new type of databases, so different from our traditional relational databases. Different. Okay. So how different? Object-oriented. So we know object-oriented programming, right? So we know that concept, object-oriented programming. Yeah, here, yeah. Then there is some similarity with object-oriented programming. Okay, yeah. So, yeah. Handling complex data structures. How do we use objects in object-oriented programming? Yeah. So think about it. We have many programming objects. So here we're talking about. So we talk about programming objects. Yeah. So we know the meaning, right? The programming objects. Yeah. So you define a special data structure to store your data in a programming object. Yeah. So you need to define a class, right? So then after you create a class, then you need to, allocate data, store data in that class. Use that class to instantiate, to create objects. Yeah. So when you start, you define classes first. So then you create classes. So then you use your classes to create objects. Okay, object. Yeah. The instances of those classes. So that's what we understand in object-oriented programming. Okay? All right. Think about when we store our data. Can we store the data with the structure of that particular programming object directly into the database? Here the idea is like this. Okay? So we store our programming objects directly into the databases. That's the main idea. Those researchers, so they try to explore this idea. Okay? Yeah. Because if you do not store programming object directly into your databases, you need to do conversion. You need to retrieve your data from your programming objects. Then you need to rewrite. Yeah, after you retrieve, you need to store in tables. Okay, store the data in a table you create. Now, because in the relational databases, you need to use tables to store your data, right? So the storage unit is table. Yeah. So here, this object relation conversion, relation, that it means a table. Okay, one relation means one table. Okay, yeah. Object relation conversion means object to table conversion. Yeah. Yeah. And because you need to do a lot of work if you want to do object relation conversion. Yeah. So the designers of this new type of databases, they want to bypass this conversion step. So they want to do it more efficiently, just store the programming objects directly into the databases, skipping the conversion step. Okay, yeah, so that's their design idea. No object relation conversion. The result of this idea have not found widespread use. So here, widespread, not widespread. So minimum use, could be ignored. The usage of this new type of databases. Too little. Yeah. All right. Yeah. So the try like this, not successful. Yeah. The problem is obvious. We know the programming object, typically they're binary data, right? So your objects, the binary data. But think about if you store the objects as binary data into your databases, people cannot edit the data through the user's interface. Right? Yeah, it's a binary data. You don't know what's in it. Yeah. So that's not convenient. Okay. Yeah. Yeah. People like to use text data. So then it's very easy. Yeah. So you can access the data stored in database. Sometimes you want to modify the data directly. Yeah. Then you can do it with text data, but you cannot do it with binary data. So it's not convenient. Okay? Yeah. So many reasons then. So this new type of database is not useful in the business world. Yeah. All right. Yeah. All right. But another idea. So then people modify the idea. Another one, modified approach. That one is very popular. In current IT industry, that idea is very popular. So the idea is called ORM technology. ORM technology. What's that? Object relation mapping. This technology is so popular in current IT industry. Okay? So object, programming object, relation table, mapping. So there is a specific mapping. The mapping work. Mapping, we know that's the conversion, right? So that's, address that conversion thing. Address that. So, but this mapping step can be made automatic. So this mapping step, if you want to do it manually, then people may not like to use, right? Not very efficient. So this step, this mapping, people want to do it automatic way. Then very efficient. Automatic way, okay? But the automatic way, in order to do it automatically, you need to do setup. You need to do setup work. Okay? Yeah. So you need to, tell the mapping tool. So there is a special tool, mapping tool. You need to tell the mapping tool how to do the mapping automatically. Okay? So you need to provide sufficient information to the mapping tool to make it do the conversion automatically. So that's the idea. Okay? Yeah. So the object relation conversion is done by ORM tool automatically. Okay? Yeah. Yeah. How to do it automatically? There are two ways to do it automatically. Yeah. So how to make it do the conversion automatic? Two ways. Two ways. Yeah. The first way by configuration. You need to do configuration. Okay, so that's the setup step. Okay, you need to configure. Okay, provide necessary information to configure the mapping part. Okay. The second actually equivalent to configuration, but people want to make the configuration process as simple as possible, or in an alternative way for the configuration. It's a different way to configuration. Yeah. By annotations, the Java annotations, current. Yeah. So in Java, the current Java programming, people use annotations a lot. Okay. So the second way for the setup step by annotations. Okay, by annotations. Yeah. Yeah. How to use these two ways? If I'd like to give you a little more details about these two methods: configuration way, annotation way. Yeah. So let me do it next time. So next time, our last slide of part C. So I give you the basic process, how to use these two ways to do the conversion, the mapping, okay? Object relation conversion or mapping. I mean, the description part, okay? Yeah, two ways, but I'll leave to next time. In our last slide, we will do that. So then we finish part C. Yeah. So then the last part D. Yeah. So we finish this module next class. Yeah. All right, so that's it. Yeah.